Boy, it almost started that countdown again. Hey, everybody. Welcome to late Spindle TV exclusive class. I almost didn't make it, ladies and gentlemen. I was up to the wire. I just finished with a digital woodcarver customer out of Texas. It was kind of a long affair. And I thought, oh, man, 8 o'clock come and went, and it was 8:15. And I'm like, oh, Lord, let me put a class together very quickly. So thanks for joining me late on a Friday night. This is a topic. Let me get JR in here. JR, thanks for popping in. Pop up in here. Hey, buddy. Let's talk about tonight tape splitting, right? G-code tape splitting. Alexa, stop. And then, with tape splitting is basically if we have long G-code runs, and this is a topic that has come up a few times. Is there, people ask, is there a way to pause or stop the machine if I can't, if it's going to run for hours and I can't, let it run or whatever the case may be? How do I stop and pause and things? Well, there's actually a way that we can set up the post processor in Vectric to split the G-code. So we can set up, if the G-code is a certain number of lines, we can say, cut off at this many lines and then create a separate file for, let's just, it's a low number. If I say 1,000, that's only like, it moving one line. 1,000 lines of G-code, but let's say we break it up every 1,000 lines. So every 1,000 lines of G-code, it would create a file and it would index that file. So let's say my G-code was called dogbone. It would say dogbone 1, dogbone 2, dogbone 3, that kind of thing. And it would create those individual index files and everything. And so we can set up the post processor to do that for us. We can set up the post processor to, look at our G-code and then however many lines that we choose, that, it'll break it up at at that many lines. And we'll look at a few G-codes. We'll look at their kind of estimated run times and everything, and then we'll see what the, what the tape splitting could do if we decided we wanted to kind of split it up. But now it's not something where you pick, it's not something where you pick, like for this file, I want to break it up, an hour and a half in, or that you set in your post processor. You're going to, for me, I have post processors for my regular machines. I have post processors for my ATC machines. I have post processors for, generic post processors and all. And so I'm not going to change those originals. I'm going to have, let's say my regular helical arcs, digital woodcarver helical arcs inch post processor. I'm going to have a duplicate of that, but it's going to be, digital woodcarver helical arcs inch split or something. I'm going to have a different file. I'm going to have a separate post processor. So when I can choose from my list, if I know I have a long run, I don't want every single file that I save to get split, right? I want to be able to choose that post processor and say, you know what, I'll split this one, because I don't want every single file that I run that's going to be long to be split. But there's going to be times that I know, I want this one split. That's just, I got to break it up. So I'm not going to override, or I'm not not overwrite. I'm not going to change or alter my original post processor. I'm going to have a copy, and I'm going to make that change in there. I'm going to show you. We're going to go through that. And then I'll have that in my drop-down list of my post processors. I can choose my regular post processor or my tape splitting post processor, right? So we'll look at that and we'll see, we'll save some tool paths and see exactly what that does for us. And so you can kind of get the general idea. But this is a great way of, like in the past, if we didn't split the tape, we may pause the machine, go to sleep, wake up the next morning and unpause, kind of thing, start up the spindle and unpause or what have you and everything. Well, this is a way where we can just run file 1, for that first whatever couple of however long, however many thousands of lines. And then at the end of that, I can run file 2 or 3 the next day, but I have to leave everything on the table. There's nothing changes there. And it also does, it doesn't change the fact that if you have a machine, let's say that you have, the digital wood carver 2440 or, a Shipoko XL or something, or whatever, belt drives or something like that. If I shut down the machine, my stepper motors, the brakes will relax. And when I start up the machine, they engage. And during that engagement, sometimes there can be just a slight jump. I mean, so slight, just a few thousandths off. But that jump throws it off. I mean, you'll see, like if I was doing a 3D model, I could tell if I stopped my machine and shut my machine down, restarted my machine, and I continued that G code, from that same line and everything, I would actually be able to see a faint line where it jumped off and now it's carving the design, just slightly off than what it was. And it throws kind of everything off just by a few thousandths, but it's still there. Nothing a little sanding wouldn't clean up and everything like that. But you're still, for me, and everything, that machine's still going to stay on until the project's off the table. But at least I don't have to worry about, right clicking on a G code line and trying to get it to start from that line. I have a tool path that's already created, basically. I have file 1, file 2, file 3, file 4, file 5 that I can run. And if I can run them all that night, right, while I'm working, that's fine. I just have to, when it's done, load the next one. When it's done, load the next one. When it's done, load the next one. And the cool thing about tape splitting is if there's a retract move, meaning that the Z raises up at the end of our post processor, if it has the Z raise up to move home and stuff, if we split, let's say we split every 1,000 lines, and let's say line number 999 has a retract move where it's raising up and going to the next location. Even though I said to cut off the toolpath every 1,000 lines, it's actually going to cut it off at that retract. So the next line is going to take over from that retract point. That's all automated, kind of the post processor, and Vectric handles that and everything. And so, which is pretty slick. All right, that's enough boring talk just to kind of give you a preempt of what's happening. Now we're going to actually get into it and take a look. So in the Vectric software, let me switch over. JR, real quick before I switch over, how you doing, buddy? You doing all right tonight? Your microphone's off. Nope. Hold on a minute. I lost JR. Microphone. JR, we can't hear you, bud. You're with us. We see you. Just can't hear you. And it shows that your microphone is on. There you go. I heard something. Click. Nope. Oh, I heard a click. Like I hear a click, like, something's clicking on, but then you're muting again. Give us a second, guys. Let's get JR's audio figured out here. So you were, oh, there it was again. I can hear where it's trying to kick in, but then it goes right away again, JR. So not sure if it's plug thing or whatever, but I got you. Let me reboot. All right, we'll see you back here in just a moment. But I'll keep an eye out for you. All right, ladies and gentlemen, while JR is rebooting, you won't miss too much, JR. I'm just going to get the guys pointed and girls pointed in the right direction here. So we're going to jump over to my screen share. And we're going to share an entire screen, and we're going to go to the Vectric screen right there. All right, first things first, post processor. For those that are like, kind of not new, but, just like, not really sure what we're talking about when we say post processor and things like that. When we are in our tool database and we're looking at our machine setup, there are associated post processors, meaning that when we save our tool path, we're going to choose, there's a drop-down list where we choose a post processor, and this is what creates the G code. And the way your G code is formatted for your machine, whether it be Gerbil, GRBL, or whether it have, and in front of every line, there's a line number or, a .tap file, .nc file, things like that. This post processor basically tells the file how to organize, the G code, the coordinates and all, and what characters, for M3 to turn the spindle on, M5 to turn it off, that kind of thing, right? So this post processor provides all that information in your G code. And we'll take a look at a G code, and then we'll kind of compare it to the post processor here in just a moment. But in your Vectric software, with your machine setup, if you've got your machine set up, you're going to have an associated post processor with it. But in the software itself, when we are over on the toolpath side of the software, when we're hitting save, there's a post processor list here, and that post processor that we choose, that's associated with our machine or what have you, that's what formats the G code. That's what formats the file that you run in your controller. Okay, so that's the post processor formats the G code file in the proper language or layout or whatever, so your machine can do all of its functions and features and all that stuff. So I have a helical arcs for our machines that don't have ATC, automatic tool change. And then I have a similar post processor that has ATC. So that way, if there is multiple tools in the file, it provides that M6 code and then the tool number, M6T1, M6T2, and it goes and picks and drops off, tools as it's carving, right? So my regular post processor, if I tried to run that machine on my machine with ATC, it wouldn't do ATC. It wouldn't drop off and pick up tools. But my other post processor has that layout to where it throws in that formatting for the M6T1, M6T2, that kind of thing. And so that's where you'll find it. Now, where you'll actually find it in your list, mostly, hopefully, if you go to the File menu and you go to Application Data Folder, Open Application Data Folder, in that folder, there's a folder called My Post P. Now, there's also another folder called Post P, and this is kind of the default folder that's always traveled around with Vectric. And this is like some of the most common post processors out there for different machines. Miscellaneous old Mach 3 post processor, Haas post processors, Bridgeports and, Turbo CNCs and things like that, right? So all these older ones and everything. There's an entire list of those post processors under the Post P. But the My Post P folder, that's the one that should have your post processors listed there, so that when you're in your drop-down list, it doesn't show that entire list. It just shows your specific post processors for your machine. If you don't have anything in the My Post P folder, just the README file, then typically, yours will be defaulted to the last one you use. But if you drop down that list, it's going to pop up an entire list of G codes, that aren't even related to you, right? Well, if you populate your post processor files in the My Post P folder, then that overrides it, and that's all you're going to see in that drop down over here in the Save Toolpath file. Now, under the README file, Basically, the README file just says custom post processors placed here will be outside of the Vectric post processor update cycle. If you simply want to mark most often used or favorite post processors, please do so from within the software. And that simply just means that you can have in your machine setup and everything, you can have your most common post processors and everything in there. And so it really doesn't make a whole lot of sense. But long story short is it's saying that if the company sends the post processor to Vectric updates that post processor and puts it out with all its major releases and everything. If I have the post processor, if I'm using a custom post processor here in the My Post P folder, then if I'm just a user and everything, my post processor is going to be my post processor. But if the company that made the machine updated it somehow or added something to it or took something away from it or whatever, I wouldn't get that update. And I'm okay with that, because if it ain't broke, don't fix it, kind of thing. And since I write all the post processors for Digital Woodcarver and things like that, I'm good with it never updating, right? But you may not be. You might want it in that folder, but you can go there. Now, in that, if I open up the application data folder again, if I go back to the application data folder, which I'm already in right here, and I back up, the Post P folder, this is where you could create a folder, call it favorite post processors, like they're talking about in that README. Favorite post processors are most commonly used or something like that, and you could specify that be the folder that you want to kind of like point to and everything, but it'll kind of come up. All right, let's get out of there and let's look at an actual post processor file. Now, I'm going to try to increase my font for you on the screen. Okay. Let me hide this. Well, GRBL, yeah, I mean, GRBL can be metric, but also it can be inches too. So it's just the same thing as a G21 or a G20, metric or imperial. But Gerbil require, so there's different, there's like, Gerbil, with Gerbil, typically with the Gerbil post processor, your line number, there's always a line number in the front of the code. But there's definitely like G0, G1, G2, G3. Instead of, let me open up a toolpath. And you see on the toolpath here where it says G1, but then there's nothing here. And then it says G2. So in my post processor, G1, as long as all of the next lines preceding fall under that G1, that linear move, then they don't need that G1 to be written for every single line that it does. And the only time a G code pops up is when it changes G2 clockwise, G3 counterclockwise, that kind of thing. And so this is a clockwise move for going around that corner, a curve and all. And then all of a sudden it goes back to a G1, a linear move, straight line linear move kind of thing. And so in Gerbil, the G1, it would say G1, 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 G2, G2, G1, 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 G1. It would be in front of every single line. And then typically in some cases, depending, it's not always, but and sometimes the F code, your feed rate, would be at the end of every line. Like, you know, for this particular post processor, the feed rate, when the feed rate changes from a plunge rate, like the Z is plunging down, this first F code, then the feed rate starts, 75 inches a minute. Everything runs under that 75 inches a minute. Nothing changes through, until there's another F code. So if we look here, plunge, it's raised up, it moves to this location, it plunges the Z, and then 75 inches a minute, it's making that cut until it gets to its next, Z positive move, and that next plunge, right? F25, the next plunge, and then again, linear cuts all the way around, right? So in some cases, the G code requires an F code all at the end of every line. And that, you'll see that sometimes a lot in rotary that is using the term, it's not intermittent time. There's a term. If anybody's a really into it, rotary carver, basically it is, hold that thought, it is inverse time. So if the post processor is set up to for inverse time, then what that means is it says, hey, this move has to go from point A to point B in the time period of 3 seconds, right? Inverse time. So by the time I turn 45 degrees, my router has to be, as that is turning, my router's moving, and the timing, by the time my spindle gets to 45 degrees, my router's got to be at the other end of that cut. And it's going to be a 3-second cut, inverse time. And so that would require the F code to be at the end of every line, kind of thing, right? So that's getting off of tape splitting, but that's just kind of G code. So, and if I did an Aspire project in millimeter and I use Gerbil inch, would I be in trouble? No, because your software can read inches or millimeters. So if at the beginning of the G code, let me go up to the top of my G code here. Around the top of the G code, and I don't think I specify in mine. Give me a second. Yeah, I don't specify unless it's absolutely necessary. But at the top of the G code, it would say G20 or G21 if it's millimeters or inches and things. So when my inch here does not say the millimeters, but if I switch to millimeters, it'd probably say G21. G21. I get my G's mixed up. Give me a second here. Give me a moment. G21 is, inches is 20 and millimeters is 21. So yeah, G21. If I was working in millimeters, it would say G21 at the top of that and everything. You wouldn't necessarily be in trouble. It would interpret it, but now if it doesn't interpret it, if it doesn't tell the software that we're working in millimeters and our software is set up for inches, then it's going to assume that's inches. And I've had that before many a time. Let me show you an example of that. Let me show you an example of that and what happens here. Give me just a second. First things first, I've got to find a post processor that's millimeters. So let me see here. Let's go to G code, generic G code, millimeter, dot tap. Okay, apply that and okay. All right, so I'm going to create just a simple circle cut. And I'm going to, this circle, by the way, is 5.2 inches in diameter. I'm now going to save that in a millimeter. Well, first of all, I got to create the toolpath. So profile cut, we'll cut 1/8 of an inch deep with a 1/4 inch end mill on the line. Let's do on outside of the line, and we'll calculate that toolpath. And then I'm going to save that toolpath with the millimeter post processor and sample millimeter. Now, let's first look at that in here. So file open. Let's go to download sample millimeter, and let's look at that here so we can see the G code. And now this Vectric Post Processor here, this generic one, it, as we come through, the G code is starting right here, but there is nothing here specifying G21 that we're in millimeters. Nothing telling the software that we're in millimeters, right? So it just says G0, that's supposed to be 12.7 millimeters, right? 0.8 inches, 12.7 millimeters. Let me, give me a second here. 0.5, sorry, 0.5 inches, 12.7 millimeters. Now, my machine, if I were to save this with inches, right? Like if it inches, because my machine runs on inches, when I hit start, it's going to raise, it would normally raise the Z up to 1/2 inch, 0.5, right? But if I ran this G code, it's going to try to raise that router up to 12.7 inches because there's nothing telling it that it's running in millimeters. There's nothing telling it to change from inches to millimeters. So if I open this up in my controller program, okay, and my first line of G code is G0Z 12.7, nothing's changed me from millimeters to inches and things. And if I look at my circle. Now, this is my machine right here. This is a, just so you understand, right? My 5.4 or 5.2 inch diameter circle, 5.2 inch diameter circle. This grid right here on the table is a 4x8 CNC machine. You see my circle right here, right? All right, just make sure we understand that. So the moment that I hit start, I'm all zeroed out. Yeah, zeroed out. The let me really quickly type in -7. Oops. And let me zero out the work. Okay. So the moment that I hit start, the first thing that the job is going to try to do is going to try to raise that Z up, right? And it is, you know, it's now, you know, all right. So I don't have a spindle. I don't have ATC and all that stuff. So it is, it requires, let me save it with, bear with me a second. I need to have a ATC millimeter post processor. Well, anyhow, it raised it up to my safe height. But I got to get past, give me a second. I got to get past the, I need to get past, all right, let me edit my G code. Let me load my G code. Let me take out this T1M6, delete, verify, no errors, refresh. Okay. All right. So I took out the T1M6. Let's start again. All right, so let's stop here. All right, so now 12.7, 12.69999, right? 12.7. My machine was only supposed to raise up a half inch, right? Not 12.7 inches. I don't have that much clearance, right? So there was nothing in there telling it, there's that I'm in. So if you work in Aspire and your Gerbil is set up for inches and all, then you need to save with the GRBL inch post processor. If your Gerbil is set up for millimeters, you need to save for a millimeter post processor, or you need to at least add in that G code. So if I edit my G code again here and I put in G21, verify, refresh, and let me re-zero out. Let's pretend I'm re-zeroed out here. 0, 0, 0. So let's pretend that this is where my project is. Now look at my circle, right? It's more of a 5.4 inch diameter circle. I'm in my table now, right? So it knows just because that G21 is there, it knows I'm in millimeters. So when I go to raise up, now I'm running in millimeter on this because it converts it and everything. So when I go to raise up, you see it raises to the half inch, right? Even though my G code says 12.7 millimeters, it converted it because of the G21 in the G code. So you just want to make sure that your post processor is putting out that G20 or G21 so that you're good. So that way, if your Gerbil machine is set up for millimeters, but you save it in inches, as long as it knows it's in inches, G20, at the beginning of the G code, you're good, Kurt. If you're running in inches on your machine, but you save it in millimeters, as long as it says G21, you're good. Okay? Good. That was a good question. Good question. All right. So let me turn that off. Okay. Now let's talk about tape splitting. Okay. So in post-processing and everything. Now, this particular G code right here, right, is only 593 lines. No, you wouldn't be, go into your post-processor and add in the G21 in the header. So you wouldn't be screwed. Just make sure that you add the G21 in the when we're looking at the post processor here in just a minute, I'll show you where the G21 would go in the header of that post processor. So that way, when you do save it, it'll tell the software, inches or metric or whatever. Okay. All right. And typically, like right now, all of our machines run in inches, so we don't have a millimeter post processor. We have an inch post processor. But if they are working in inches in their software, or if they're working in millimeters in their Vectric Aspire software or something like that, then we would definitely, when they save their file with the G code inch post processor, it should have the G21 in there or G20. I'm not sure. I actually never, we have them just running inches or something. All right. So I'll look at that. We'll look at that we'll create a design here. Let's do it right now. So I'm going to set up this job to be millimeters. And so I'm going to click OK. So now I'm in metric. No, I don't want to recalculate just yet. Okay. Let's go into the tool database. Yep. I want to go an 1/8 inch deep, 3.175 millimeters. I'm going to use a 1/4 inch end mill. That's fine. And I'm going to calculate that. I'm going to save this with my inch post processor, my normal inch post processor. And I'm going to call this sample millimeter inch post processor PP. We'll see. And let me do kind of like a dash, right? Dash inch PP. Save. All right. So if I go back into my controller and I load that file that I just created in metric, but I saved it with an inch post processor, I'm going to open that file up and everything. And what we'll see here is the size of this circle here. Okay. Now my router bit, let me zero out here. My G-code and everything here has got me raising up a 1/2 inch. I'm moving 3.5 inches, and then I'm doing a cut. So let me see here. Let me go to my program details. Trying to do math because this is reading from my machine tab. Let me bring my machine down to 5. Let's say the machine, let's tell the machine I'm at 5 inches and 5 inches. And -7. And then let me zero this out. Okay, so on my maximum X travel, I'm zeroed out in the center. So how big is my circle, just so I know? Okay, my circle is 175.6 by 175.6. Give me just 2 seconds because I gotta refresh myself on that one. 175.6 is 6.91 inches. Okay, so 6.91 inches. So let's do this. Let's make it an even 5 inches. $127 millimeters. And let's recalculate the toolpath. Get down this rabbit hole real quickly. I'm going to go on the line for this, just so I don't have to accumulate for the bit. 1/8 inch cut depth, calculate. Okay. So now, one more time, close, save, inches, save, that, delete. All right, file, reopen that. Okay, so when I hit start on this, it's only raising me up 0.01 inches because that's what 0.5 of a millimeter is, 0.197. So the 0.19685, blah, blah, blah. So 0.197. So it's reading right now inches because that's what my software is reading, but my design is in millimeters. And so it's only raising me up on that 1/2 inch. It's only raising me up, 0.5 millimeters because I saved it with the post processor, 0.5 millimeters and all. There's nothing telling my software There's nothing telling my software that that hey, I'm running in inches. Now, if I change my post processor, in this case, I'm going to edit my G code, and I put in here G20, capital G. Let's do that. Let's be proper here. G20, and I verify good, refresh. Now, if we look, my hole is the proper size, and when I hit start, I'm going to raise up to that 1/2 inch, right? And now it knows, even though I designed it in metric, it knows to convert it to inches because of the G21, right? So as long as you have, long story short, as long as you have that G21 at the beginning of your toolpath, or, G20, if you're in metric, as long as it knows what to read, like, hey, this design is metric, this design is inches, whatever the case may be. Now, this design is metric. I created it in metric, but I saved it in inches. So my post processor is inches. So G20, it's got to convert to inches, not metric. It's got to convert to inches so it runs proper. If my design were in inches and I saved it with a millimeter post processor, the top of my millimeter post processor has to say G21 so it knows that I saved this in metric. I might have designed it in inches, but I saved it in metric. And you're good. All right, hope that clears that up. Okay. All right. Whoop, didn't want to exit out of that. Give me a second to give me a second. Oh, let's see here. Documents, Planet CNC, shortcuts, 5100. Okay. Now let's get back to the topic at hand. Tape splitting. So case in point, let's close this post processor here. Here is my helical arcs post processor, my standard helical arcs post processor, no ATC or anything like that. Now, at the post, with a post processor, the format, and if you ever want to know, like if you ever want to kind of like follow along and read about this, right? In the Vectric software, let me go back here, under Help, Post Processor Editing Guide, that will open up a document that looks like this, which basically kind of what the post processors do, and then it walks you through kind of the sections of a post processor layout, right? So all the sections from beginning to end of a post processor. Now, give me just a moment to pop myself back in there. Let me get back to where I was. There we go. The post processor lays out like this. Most of them do anyway. So from Vectric, your top section is kind of like your main section where you have the history of the changes or the modifications or anything to your post processor. Any editors that are involved with it and all, you would put the date and who made the change and all, so you can always refer back to them and stuff. The next section is what gives the post processor its name. In our case, the digital woodcarver helical arcs inch tap, right? The GRBL inch tap or, inch CC, NC or whatever. The file extension is what file extension it's going to get saved in. So .tap. And then the units will either say inches or millimeter, depending on what it is, right? Now, here is right under this section. This is where we're going to be working, where this blue line is or purple line is. We're going to be working here to add in the tape splitting code. But I want to kind of just come down. So basically line terminating characters, like at the end of the line, is there a comma? Is there a semicolon? Is there whatever, a period, which there would never be. But anyhow, what's at the end of the line? What characters there are. Now, I'm not going to get into all the specifics on coding and all that stuff, but this 13 and this 10 means something. In the ASCII, ASCII code, the bracket 13 and the bracket 10 are special characters. Let me Google search it really quickly just to kind of get one real quick here. ASCII. Basically, the ASCII code 13 is a carriage return. It's like hitting enter on the keyboard. All right. And then the ASCII code 10, it's basically a line feed character. It often denotes as I could, if I wanted to, use a /n, which means like next line, right? That kind of thing. So both of those basically are telling it at the end of the line to go to the next line, right? That's all that's doing. Now, again, I'm not going to get into the coding and everything, but that's, those numbers and those brackets, those square brackets, they mean something. And the 13 is carriage return, hit enter. Or if I wasn't using a carriage return, I could use the /n, which stands for new line, right? That kind of thing. So those could be in my post processor when I'm coding and scripting and things like that. All right. Now, line numbers. Line number start, line number increment, line number maximum, right? At the line numbers, you can set like your maximum number of lines and things. And this is blocking. This has nothing. This is blocking numbering and all. So each block of code, each block of toolpath code can have 999,999 lines of G code within each block, from the, raise and go and everything. And then we get variable formats, what do we want to see in the G code, X, Y, Z positions and things like that. So it goes on and on and on, the different types of file details. So in my G code, I have file details in my post processor so that when I save my post processor, when I open that G code and everything, the very first part of the G code is the file details, right? So everything in there is the file details. And that is this upper section of the header. Right after the header, that's what I want. I want that file information. And any notes, file notes that I put in the software are going to show up here, anything like that. And notes in the software, if I wanted notes to show up on my G code, that's under the edit menu and down here notes. So like when I type in notes and everything, those notes are going to show up in my toolpath, right? Because I have that, I have it specified that I want to see notes, in that post processor. And if you ever looked at you can open it with Notepad. I'm using Notepad++. That's what I use for. It's a cleaner editor for me. But the from the header with the notes in, now my G code starts. G17, blah, blah, blah. This is where in the post processor, right under the header, begin job, right? This is under the begin job category right here. This is where I would put my quote G20 because I'm inches. This post processor is inches. And that's where it would be, right above the G17. G17 is telling the machine that I'm working on my XY plane, and things versus my, XZ or YZ. I'm working in my XY plane. And so I could put that in there, G20, and it knows that that's inches, the incremental inches, right? If I put G21, it's going to interpret, when I save this toolpath, it's going to interpret everything as millimeter. And I would want to make sure that if I put G21 here, then I need to darn sure come up here and change this to millimeter under units. And I would darn sure come up here and make sure that that says millimeter instead of inches. Right? Right. Okay. All right. Now, let me really quickly, Kurt says, G-Sender won't let me look at a job without being connected. I'll check if G20 or 21 is the first line. That was the answer. Cool. All right. So now here under the header, let's look at the instructions that Vectric gives you, and let's look at, all right, if I look at these instructions that Vectric gives you, how do I know where in this post process, where do I put that information that it gives me? Where do I put it at? Right? Where does it go? Well, if we look, we're going to pull it back over on the screen here. When we're looking at the instructions, going all the way back up to the top of the page, right? So post processor editing. We're going to come down, and it talks about examples and gives you things that examples do. But now the post processor sections, the sections of your post processor. From the file comments, like this is what I talked about, like if there's any editing, who the editor was, what the date was, all that stuff. And then the global file statements, like what's the name of the post processor, what units are you in, that kind of thing. We just talked about that, right? And the file extension, .nc, .tap, .txt, that kind of thing. And so that global file statement would come down here. So the next section is going to be tape splitting. That's where we're going to be. And after that section is line terminating characters, right? So by looking at these instructions, we know that we're going to be between the global file statements, the file name and all that stuff, and the line terminating characters. Okay, that's where we're going to be. So the tape splitting is going to be in between those two. So when we're looking at the post processor, here's my file name and everything, and then here is the terminating character. So I need to be right here in the middle. Now what we're going to do, notice that there's these dotted lines with the plus signs. So the plus signs with kind of these dotted lines are like section headers, right? So we need those plus signs to represent, hey, do not read this section. Do not put this in the G code. This is just a section header kind of thing, right? So what I would do is I would copy this section header, and I'm going to give myself a little bit of a line space. So I'm going to hit one line down, and then I'm going to paste that again. And again, I'm going to hit one line down. Give yourself a little space between the headers. And then in this copy that I just pasted here, I'm going to put in tape, tape splitting. Okay. All right. And so, simple enough, tape splitting. Now, anything here in outside of the plus signs and between these plus signs are going to be the code that I put in to specify what I want for the tape splitting. Now, if we look at the instructions for tape splitting, it says a section that describes how long the toolpath output will be split. All right, how long the toolpath output will be split. Basically, tape splitting equals, and then we put in the maximum number of lines. We put in the line total. We put in the file format, .tap in my case. And then we put in a starting index. In this case, starting index is going to be 1, the number 1, right? And then I want the index on the first file and everything, 1, 2, 3, 4, 5, 6, right? I want to start from the first file. So the answer, if we look at this like, okay, what this is telling me what I have to have in the line of code, but this next line tells me how I lay out the code, right? So tape splitting equals, just like this up here, tape splitting equals, then the maximum number of lines is 1,000. For the blocking and everything, the total lines will be 100. And 100 is fine. I'm not sure what the block section, really relates to, but we'll read about it here in just a second. We'll understand it. But this is the important part now. This is important. We're writing this code out in the post processor, so we need these characters right here. So this quote mark, percentage, and lowercase s is kind of like, the start, of our, whatever our file name is, right? Underscore percentage D, that's the little character codes for my file name, or my index, should I say. My file name is going to be this. My index is going to be this, underscore 1, underscore 2, underscore 3. And then it's going to end with .tap. And it needs to be in those quotes. It needs to know, hey, this is your format. Whatever you name the file, underscore percentage D, which is the indexing 1, 2, 3, 4, 5, 6. Then the next section is the starting index right here, starting index, which is 1, the number 1. We want to start with the number 1. Then again in quotes, we are saying yes or no. So the answer is, the question in a sense is index on the first file. And the answer is going to be yes. We want the index to start from the first file and be on the first file. And then it'll, each file name after that, it'll go 1, 2, 1 will be the first file, but then 2, 3, 4, 5, 6, 7, 8, whatever. However many files it needs to break it up into. So this literally is your code right here that you can copy. And you can go into your post processor, and in this section between those plus signs, right here is where you're going to paste it. Okay, but this is where you're going to specify where's your cutoff point, how many lines. Now let's just put something into perspective for a moment, okay? I'm going to open up, if anybody was with me in lithophane class last night, in our lithophane class last night, we did this grizzly bear. Now, this particular grizzly bear here has a total line count of 2,175,312 lines of G code. Okay, and of that 2,175 lines of G code, if I scroll down, and I really want to stress this, I want to kind of show my design. I want to zoom in to the bottom corner of my design here. Okay. So this bottom, let me get really into it. Bear with me just a second. Let me get really up close and personal. All right, right here, this starting point. All right, that point right there, that is line 49 for me. It's only in the G code. It's 1, 2, 3, 4, 5 lines in, right? Line 49 for me, because my G code has file information and post processor ATC information. You know, it tells about the tools that I'm using and all that stuff, right? So, but that's line 49 for me. Now, if I told my G code to cut off every 1,000 lines, if literally, I want to show you 1,000 lines. If I come down here to 1,000 lines of G code, right here, and I zoom out, that red dot indicates 1,000 lines. The blue dot indicates my starting line, right? Line 49 for me, right? So that, this here, right here, all of this little bit of movement back and forth to get to that point right there, that's 1,000 lines. Now, mind you, that's only going to be just a few seconds or a few minutes of a run, depending on your feed rate and all that stuff. So realistically, you know, when it gets all the way to the end of the line here, that's going to be 2,175,312 lines of code that it ran. So from point A to B to here, 2 million lines in between that, right? So I do not want to set my line limit to 1,000 lines, because could you imagine how many files that would be for that one toolpath? Oh my goodness gracious, right? So we need to be kind of realistic in everything. And so I might, break this up into, every 500,000 lines, which would be kind of like a third of the way right here where this blue mark is, right? Let me zoom in. This blue and red mark right here. That's line 499,353. So that's 500. That's about a third of, if we divide it up into 1/3, 2/3, 3/3 kind of thing, that's about a third of my project. And so I could say, you know what, that would be every 500,000 lines would be my cutoff. So at that point, every 500,000 lines, it's going to create that index. You know, it's going to create file 1, 2, 3, 4 in our G code, right? So you got to kind of figure out for yourself, what is your cutoff point? And it needs to not be a small cutoff point, because literally you can run through, 200,000 lines of G code in a matter of minutes, right? Kind of thing. And so we really want to kind of figure out, and give me just a second here really quickly. Give me just a moment. Give me just a moment. I got to get my mouse functioning. All right. So sorry about the interruption. The bear was estimated in Vectric as a 12-hour job, but the Planet CNC estimates the best time to be about 7 hours, 7 hours and 5 minutes and everything. Now, my worst time, my raw time, 32 hours, right? But my best time, 7 hours and 5 minutes is what it's estimated at, and everything in there and everything. So in 7 hours, run that 1 million lines of G code. To answer your question, Kurt, so in Vectric, Vectric estimated it. I believe it might have been like a 12-hour job or something like that, depending on what it was and everything. And that's another thing really quickly. In my settings, right, I could run a stopwatch and run my job, any job, right? I could run a stopwatch at the same time as I hit start. And when that job completely is finished, router raises up, shuts off, at that point, goes home, shuts off, hit my stopwatch and everything. And I can look at my estimated time in my controller software versus my stopwatch, but also my estimated time in my Vectric software versus the actual runtime, because the Vectric software can't calculate for acceleration and deceleration, on ups and downs or around curves and all. All it knows is my rapid rate is 500 inches a minute on this machine, and my scale factor is 1.3. But I can change the scale factor in the Vectric software to change the estimated time to be closer to the actual runtime. And I can start to kind of fine tune that estimated time to be more in line with my runtime. And in my controller software, I can go to the file menu and into the settings. And under the user interface of the settings, I have a runtime correction here. So I can look at my actual runtime versus my estimated time, and I can change my runtime correction to make my estimated time more in line with my actual runtime and everything. So because again, it's an estimated clock, it's not an exact, right? So I can adjust the runtime correction to get more in line with what my machine is running those jobs at, and things like that. So there's two places that I can, one, the Vectric software under the little clock, or two, in my controller software. And I don't know any other controller softwares or where that would be and all that stuff. But if your controller software gives you an estimated runtime, or if it has a countdown clock or anything like that, you could time it from the moment you hit start. Don't time tool changes and all that. Run time. Right? So create a file where there's actually no tool change in it and all, it's just one bit. Time it, and then kind of look at what your software is telling you and what your Vectric's telling you versus what it actually ran at, and then you can kind of start adjusting numbers. All right, let's get back to it now. We got to get back to it, get back on track here before we get down in the rabbit hole. So in my case here and everything on the tape splitting and stuff, I'm going to go ahead and put in 500,000. And on the no decimals, none of that stuff, ladies and gentlemen. Okay, now let's talk about the 100 here. Now I'm going to go back, and Vectric doesn't really do a great job of explaining that, but let's basically understand what if we wrote this code, 1100.tap, 1 and yes, what it leads to, what's the output, what's it saying, right? That kind of thing. So if we look at this, it says output will split into multiple files with a maximum of 1,000 lines. Okay. However, it's important to note that if there's any retraction in the footer section of the post processor, if a retract move exists after, let's say not line 900, which is not 1,000 minus that 100, that's that number right there. So we can say, hey, we could give it a number, 200, 500, whatever. If there's a retraction move anywhere within that back 100 and all, the file will split at that move. So basically, if my router is carving and it raises up to move to another section, that retraction move to move to another section before it carves again, then it's gonna, if that move from line 1,000, if that move 100 lines back, if that move is anywhere within that 100 lines, so basically back to line 900, then it's going to split the tape at that retraction. That way, where it's retracting, that's where it'll retract there, and it'll end the G code right there. And then the next G code will pick up from that retraction and go, down to the next carve and carve, which is great. It does that for us automatically, but we have to give it a count. If there's a retraction, how far back do we want the G code to look for a retraction? Right? Now, here's the thing about that. In a G code where we're doing a 3D model file, okay? Excuse me. In a retraction where there's a 3D model file, let me go back up to line 1 here. In a 3D model file, that bit stays down in the cut for the entire cut. It rides. It only goes up and down, for going over the hills and the detail and all that stuff, but it never retracts, Now, I say that, but in some cases in doing details, there's lots of retractions where it's going and touching off this little 3D, touching off this little bit, touching off this little detail, touching off that little detail, And so at the beginning of the G code, there's some retractions right here where the router goes to one location at a 1/4 inch above the material, then it plunges down and it carves, and then it retracts again, and then it moves over and then comes down and carves, And so at those retraction points, those positive Z movements, if there's a positive Z movement like that within 100 lines back, it's going to find the nearest one, and that's where it's going to retract. That's just going to stop the code there, right? And it'll pick up the next code from that point. That's all it's saying. So if I go to line 500,000 in this G code, bear with me a second. If I go to, come on now. We're almost there. Almost there. Almost there. Okay, right there. So if I go to line 500,000, my Z, my negative Z, my Z is riding that bottom and everything. It's riding. There is, right here, we have a slight change, but no, nothing there. So there's no retraction there. So we come back and those are all negative Z, negative Z, negative Z. I could do a find and find a positive Z, but if I just I can't tell to look for a plus sign. So give me a second. I don't think there's any retracts in this file, so let's see. All my Z numbers are here. I can see. If you're wondering how the hell can you read that if you're scrolling so fast, I can see when my Z changes from a negative to a positive. Nope, no retraction there. Nope, no retraction there. Oh. Nope. So I'm already 496,000. I'm already 4,000 lines back, right? And I'm not, there's no retraction moves for this particular. It stays at the bottom through that entire cut. There's nowhere it's going to raise up to go anywhere else. So for me, this, I wouldn't really, when it comes to 3D models, it's going to just end at 500,000. But if I was running a carve where it does have a lot of ups and downs and things like that, retraction to move to this point, to that point, like let's say a V carve sign or something like that, and stuff, it's going to, how far back from my 500,000, how many lines back do I want it to look for any retract point, right? That kind of thing. So for me, I would probably say, to look back 1,000. I could even go 10,000 lines, right? Look back 10,000 lines, for something like this big, because it's here it's going to go 400. If I go 1,000 lines, it's going to go 499,000. If it doesn't see any retract, then it's just going to end at the 500,000, right? So it's going to stop it right there. Now, all right, so let's go ahead and save that. And now I don't want to save this as my helical arcs. That's my original. And I think we talked about this in the beginning. Did JR ever make it back? No. JR, where you at, buddy? Let me know if you're in the chat still, JR, because I don't see you back with me. But I don't want it to overwrite. I don't want my original. I want to have a backup. I don't want every file from this point forward that I save with my helical arcs to break off at every 500,000, right? I want to be able to choose what toolpath I save under this post processor, what toolpath I save under my normal post processor. So here in the the file name, I'll probably get rid of, because you can't have a very long file name, right? So I'll probably abbreviate this to DWC, and then I will put split. Helical arcs ends tap. Okay, and so that'll be my file name, and then I'm going to go File, Save As, and it's going to be a all files, all types. I'm going to go, for me, I'll just show you where it would actually be in your Vectric software. So in Vectric, get Vectric back up here. The application data folder is not really easy to kind of get to, but it's under the C drive and program data, Vectric Aspire 12, right, is where these folders are. And so also, it may or may not let me save to this file if I don't have administrative write permission. So I might have to save it to my desktop and copy and paste it, whatever, right? But in this case, I'm going to try to, on this root directory here, hold on, Control C to copy that. That root directory, I'm going to come back over here to my dialog, and I'm going to paste that there and hit enter. I'm going to go to my post P folder and I'm going to put it here, but I'm going to call it DWC split helical arcs inch. And I want to make sure, it's very important that I put .pp at the end. So all type file .pp, it's a post processor, hit save. Okay, now anytime you put something in your application data folder, you need to close your software. So I'm going to close my Vectric software and this one too. Let me save this one real quick because I'm doing a test on my my Planet CNC touch block. So give me a second. Let me save this really quickly. This is just a touch block test. Okay, save. Close out of that one. And let me go to my task manager because for some reason that one down there is not closing itself. So let me just end that task. Okay. Now let's go back to Aspire and open it back up. For me, Aspire, VCarve, whatever it could be. All right, now here's what it's saying to me. Hold on a second. Unknown statement found in the line of the post processor. So it told me, it's telling me that I have an error in here, and the unknown statement found. Oh, oh, hold on a minute. Hold on. You got to click OK. All right, so I had an error in the code. So here I have to have, and that equals, I've got to have the quote marks here and here, the starting and ending quote marks. So state splitting equals quote, quote at the beginning and the end. Got to close it off just like this, kind of thing. That should do it for me. If not, Vectric is kicking my butt here. Hold on a second. Let's close that and let's restart it. It'll let you know when you go to open the file, the program. It'll let you know if there's any errors in your post processor immediately. Yep, still an error. So give me a second here. All right. It did not like that formatting. So I'm going to get rid of this, that, this, and that. Also, make sure there's only one space there. All right. This is what I'll tell you right now. Also, give me a second. There needs to be a space here. It's very important, and a space there. So the code could have been 100% correct to the way I had it. Yeah, I got you, JR. So the code could have been 100% correct the way I had it, but if I don't have my spaces correct, the spaces, notice on every one of these, there's a space and a space, right? So that code, I might have screwed myself up right here by getting rid of those quote marks, and it was just the simple space on the equal sign, right? Coding is like strict. So we're going to save this, see if that corrected it. If not, then I'm going to put everything back the way it was. I'm just going to put my proper equal sign spacing and everything that was missing. So it's very important. I'm looking over here, but I should be looking here. It's important that the camera's over here. You guys are over here. I'm watching what everybody's saying. Anyhow, the spacing and all that stuff is super important and everything. And Vectric gave me the sample of code, but there was no space on the equal sign. So it probably threw the error, but all those other quote marks and all were probably correct. Let's see if we get one more error, and then we'll go back and we'll copy and paste again, correct it with the proper spacing, and see if that corrects it and everything. And it's literally, it's kind of, unless you're a coder and all that stuff, it could be, numerous things. Let's find out really quickly. So right now I'm saying that this is my string in between these quotes, but I eliminated those quotes in there, and that was probably the wrong thing to do because that's not what the instructions said. Let's find out. Let's go to save, close out of the Vectric software, reopen the Vectric software, and see if it throws another error. If it throws another error, which it did, now there's even more of a problem, right? So there's no space in the string, blah, 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 all because I deleted all that stuff, right? So it's telling me everything that, that I did wrong. So here's what I'm going to do. I'm going to get rid of this quote. 500,000. I'm going to put the quote back here. I'm going to put the quote back here and at the end of yes, just like that. But now the only difference is I corrected the spacing right here. Okay. Let's give it another go, ladies and gentlemen. Hit save. Now, in Notepad++, I have Notepad++ open as an administrator. So if I alter anything that's in that Post P folder, I can now just simply hit save because I saved it there first. And any changes I make to it are going to write to that folder. I don't have to copy and paste or save it as this, do that. All I have to do is hit save, and it's updating that file in my post processor. So, or in my Post P folder. So now all I have to do is go back. Fingers crossed, third time's charm. We got to end this class sometime or another. There you go. No errors. Yay! It was all the equal sign in the space. So let's look at this again. Let's go back really quickly and look at the Vectric instructions. The Vectric instructions right here. Oop. And the Vectric instructions gives me this as my example, a comment of this, but they didn't put the proper space before the equal sign and after the equal sign in the instruction, and they screwed me, right? Right? So if I'm copying and pasting that, I'm like, okay, that's the example. That's the example I should use. I can copy and paste that, change my numbers just like we did. Everything is golden, blah, 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 whatever. And, but I get that error. If I didn't know what to look for or what to change, I would be sitting here going, oh shit, what'd I do? What'd I screw up? What? I just followed the instructions, but it's not working. Why is it not working? That kind of thing, right? So documentation matters. Even right here, line ending, no space, right there before that equal sign, or after before that first quote mark. And if I were to remove those spaces and did exactly what it says in the instructions, I'd receive an error, right? As a coder, it's one of our biggest frustrations. All right, there we go. So now Vectric did open up. Wonderful. I should now be able to go into my software, and I should be able to go over to my Save Toolpath window, and I should be able to have my add a post processor split. Got to add it right there. Click apply. And there it is. TWC split helical arcs, right? So now I have a choice. You gonna let them know to make the change? Dude, they wrote the Aspire software. I'm not going to correct them. But yeah, I'll let them know. That, hey, just so you know, in the instructions, if someone were to copy and paste, there's a little bit of an error. Now, what they're going to most likely say is, oh, we do that on purpose, because in the program that we write all of this code in and instructions and everything, if we put the space in, it would cause a formatting error, blah, blah, blah. So they could at least in the notes say put a space before and a space after the equal sign if that was the case, whatever the situation is. But yeah, I'll mention it to Vectric and see what they say. But that's that. All right, so now let's go over and open up my Grizzly lithophane. Give it just a second to open. And this is the grizzly bear one, but let's not do the grizzly. We'll do the, let me turn off that model just so we know what we're doing. Turn that one off, turn that one on. So that's that lithophane. Hey, did y'all watch the lithophane class last night? Think that was interesting and all that stuff? Anything, let me know. All right, so that toolpath is, these three toolpaths right here. I'm just going to save one of them, okay? I'm going to save my 16th inch Grizzly. That's it's a fully calculated, and see that says estimated 9 hours. My other software says 7 hours. I would actually time it and then figure out what exactly what it is. But this one here, that's the one that's kind of matches what I opened up in Planet CNC. But I'm going to save it now, and on that one right there, I'm going to save it with the split post processor. Hit save toolpath, and I'm just going to call this Grizzly. Grizzly. Now, it's going to put all of this stuff. As a matter of fact, it's already Grizzly in the first name there. So I'm just going to hit cancel real quick, hit save toolpath, and I'll just leave it that name right there. It already has Grizzly in there. So we'll hit save. This will overwrite one or more existing files. Would you like to continue? Yes. Right? Just saying my original one is going to open up. All right. The toolpath was split into 5 separate output files. Grizzly 3D Finish 1, Grizzly 3D Finish, 1 taper ball nose, all the way to number 5 tap. Okay. Wonderful. It broke it up into 5 different toolpaths. So now if I go look at my folder, and everything, I have Grizzly, and let's go to details, and you'll see _4 right here, _5, 2, 3, and 1, right? So there we have it. Now I'm going to do 1. I'll open up number 1 in Planet CNC. File open number 1, and it should be just that first section. My brain's hurting right now. Yes, right. My brain's hurting. Right. I got you. So that's going to be that first 500 lines. Right now, let's look at the G code. Right. Let's go all the way to the end of the G code, and where it cut it off at line 500,000, the thing that I do not, let me see what it did here. Bear with me a second. Let me zoom in. So the line I have highlighted is the red button. Okay, so that's line 500,000. So it's going to bump over just a little bit. It's going to raise up to a 1/2 inch. It's going to return back home, spindle off into G code. Okay. So right there, it just kind of bumped over, up, and everything, and it was fine. It finished carving that last little bit. Now, when I open up file number 2, okay, so file number 2 is going to return back to this point right here, okay, where that red dot is, and it's going to plunge down. It's going to continue on, and then it's going to start, running those next lines, right? So moving those next lines and everything. And at the end of that 500,000 lines, at the very end, it's going to bump over a little bit, raise up, go home, shut the spindle off, into the job, right? It handled all that. And it handled a retract move because of the footer. The foot at the end of the footer of the post processor. Let's look at that. in the post processor, at the very, very end of the post processor in the footer section, it has the Z height raising up, G0 rapid move, Z height up. It has the rapid move to the home, X0, and Y home, YH, Y0, right? And then M5 for the spindle off, M30 in the job, right? So that footer goes in the end of each one of those 5 sections. So it'll always raise up and go back home. I'm just now running 500,000 lines at a time, and it makes that 9-hour project a little bit more digestible. Let's see how much more digestible in here. This is about 1 hour and 38 minutes of runtime, right? So line number 1, or file number 1, was, 1 hour and 37 minutes, so estimated runtime, hour and 37 minutes. So about 1 hour and a half, for each file, which could be more obtainable for someone. So tape splitting is, it's a good thing, but you don't want to do it on every single project. So giving yourself the choice, I can run helical arcs regular, or I can run the split and split up the G code. Hey man, well, I can now choose, right? That kind of thing. All right. Now I'm going to turn it over. We're 1 hour and 36 minutes into this late night 10:20 p.m. class, talking about coding and all that stuff. But I know some of you are sitting there and you probably have a question, but you're not wanting to ask it, or not, too afraid to ask it or whatever. But right now, I want this to be a bit of a teaching moment, because it's something that is relatable to everybody. Somebody may want to do this. They may want to have the option to split their long codes up into more digestible sections. And I want to make sure that you completely understand. And the code, for anybody that wanted to add that section in, right? I don't know if it'll let me in the chat. We'll find out here in just a second. But once again, just so you know, come all the way up here to the top of your code. It's going to be in your post processor, right under where the file name is and the units. That's where you're going to put the tape splitting. Okay. Now, take that line terminating characters and copy all the plus signs and all of that little header. Copy, and then give yourself a space under units, and then paste it right there, and then type in tape splitting. Get rid of the line terminating characters and type in tape splitting there. Give yourself another, you can, you see how there's a space between the code and all? We can clean this up by giving ourselves a little bit of space. Come to the end, a little bit of space, right? A little bit of space before and after. And then you'll see, then the next one will be that line terminating, right? So this right here, I don't know if it'll let me, you can look at that. That's that section right there. You can look at that and pause the video or something right there so you can see. I don't think it'll let me copy and paste that in the comments. I can try, but it won't do any good. But you can pause it right there, and it's tape _ splitting, all capital, space equals space the number of lines you want to cut off at. 500,000 was a good amount for me. Space 1,000 is saying look back 1,000 lines, and if there's a retract point at that point, stop there instead of going all the way to 500,000. And then space quote % lowercase s _ and so %d dot tap, and then the quote mark, that's your next section, another space, then 1, another space, and then the word yes, in quotes. All right, so that's it. That's it. That's that. And then all you need to do is kind of customize what you want for your lines and look back. Now, let me answer this question here. Would you say your DWC G-code console has more features than the average console? It's not our console, right? It's Planet CNC. Planet CNC, for those of you that aren't familiar with it, planet-cnc.com. Planet CNC is a controller software and hardware, meaning the brain of your current CNC machine, where all your limit switches and motors and everything plug into that board, that brain. You can literally unplug the wires and everything and plug them in to a Planet CNC control board, right? All the outputs and inputs and limits and things, the USB connection and all that stuff. And you would be using the Planet CNC software it's associated, it's together. It's a software and a hardware. And the Planet CNC is a viable solution for milling, turning, wood carving, plasma cutting, laser engraving, foam cutting, 3D printing. It's a controller board and software. And to be honest with you, I've tried Mach 3. I've tried WinCNC. I've tried Carbide Motion because everybody I teach on one-on-one classes and stuff, they don't all have a digital wood carver. They have Carbide Motion. They have WinCNC. They have Universal G-code Sender and Mach 3 and things like that. No offense to any of those controllers, and understand when I say this, no offense to any one of those controllers, but I cringe every time I have to work with one of those controllers. I personally think that Planet CNC has the most user-friendly, intuitive, advanced console ever. And I can write my own codes and functions and everything to do things. I'll give you an example. In my controller software, I'll show you the newest one that I just did. We have a warm-up procedure for the spindle, okay? We have a warm-up procedure for the spindle. It's a 15-minute warm-up. Now, my countdown clock is running every 4 seconds. So you'll see the timer 15, 14, 13. It'll change every 4 seconds, not every minute, right? Just for preview purposes only. But if I click on this warm-up sender, this warm-up button right here, this button that I put in, it's going to automatically turn on the spindle. It's going to make sure it's at safe height first. It's going to turn on the spindle. It's going to ramp it up to 15,000 RPMs. Then after 3 minutes, 3,000 RPMs, or I'm sorry, 12,000 RPMs. And then after a few more minutes, 15,000, then 18,000. And then when it gets to 3 minutes, it's going to back down to 15, 12, 5, and at 0 minutes, it's going to shut off. And through that 15-minute procedure, it's going to warm up that spindle and those bearings. So this is what my console looks like. Now, before I open the console, I just want to give you kind of a real general idea. Let me open up my File Explorer. In Adobe Illustrator, right? In Adobe Illustrator, my graphics, which are these right here. Okay, graphics, what looks like all this, from the countdown of 0 to 1, 2. These are all individual photos, right, all the way to 15. Now, these images are put together in a code, a script that runs when I push the button, and it animates those images so it looks like this. So just bear with me on this one. But when it opens up, the spindle turns on, it ramps to 5,000 RPMs, and then now this countdown timer, watch the speedometer too. It's at 5,000 RPMs. Once it gets to 13 minutes, when it gets to 12, it's going to ramp up to 12,000 RPM. So the speedometer speeds up. When we get to 10 minutes, it's going to jump over to 15,000, or 9 minutes, I think it is. But 10 minutes, yep, 15,000. And then at 9 minutes, it's going to go ahead and jump over to 18,000. And it's going to ride at that 18,000 RPMs until it gets down. Now, this is only counting every 4 seconds, not every 59 seconds. So you're not waiting 15 minutes to see this function, right? So 7 minutes, the little tickers, even the little green marks go away and everything. So all these graphics, I designed the graphics myself, and the software is running them to animate what it's doing. So if you look over, watch over here, 18,000 will go down to 15,000 right there. And then in 2 minutes, it'll go down to 12,000, or like, this one, 12,000. And then at minute 1, it's going to go down to 5,000. And then at minute 0, it's going to shut off the spindle. And it's going to say spindle stopped, warm up complete, and then that window is going to go away, right? I do not know any other controller software where I can write my own script and code and everything. This is my script and code, right? I don't know any other software where a code can be written to perform a function or to add a button to the software or whatever. Mach 3 does it. I'm sure they have buttons. I'm sure they do, but I cringe every time I try to work with one of those programs. So I've worked with them all. Limited. Now let me stress. I've worked with them all limited amount of time because of people that I train one-on-one, teaching them how to run something on their machine. I have to know their console, and we're sharing the screen, so I'm seeing all the buttons and everything. And I have not seen anything that in my one person's opinion, that touches Planet CNC. All right. And that's not just because that's what we use with our machines and all that stuff and everything. It's just, for me, it's the truth. I have a factory down the road that has foam cutters, printers, 3D printers. They have CNC machines, plasma cutters, beautiful warehouse. It's an incubator of R&D. That's all they do. So they have every kind of automated machine you could possibly want to walk into and play with. And their foam cutter just recently went down. It had a Mach 3 board in it. They paid $500 to take that Mach 3 board out. I wired in a Planet CNC board with them and gave them the controller software. And now they're going to be able to write their own codes and things for their foam cutter to do special things with tilts and all that stuff and everything, independent motors and everything. That would have been a nightmare for them to try to learn on their own to do in Mach 3, right? And the information in Planet CNC, if I go to the manual is not only phenomenal, but if I go into like the parameters when I'm writing code, I have all the code parameters that I can use. And then when I'm looking at a parameter, it kind of breaks down and shows me examples, perfect examples, that I could copy and paste to help me write my code if I didn't know what I was doing and all, because I didn't start off knowing code, right? But I'm able to write it all in that. And I don't know any other software that it's so well documented. It's beautifully done, I think. So anyway, shut up. I'll shut up about that, but that's that. Long mill, are you running Mach, WinCNC, Universal G-Code Center? What's the long mill run? What's the controller for the long mill? Okay, let's get out of that. All right, ladies and gentlemen, let's close that. And now my graphics on here, like my quick set touch off procedure, that's that test that I'm doing and all. where they're touching off to set X, Y, and Z. Or if I'm resetting the Z0, you know, all the graphics and everything, that's all me. They can switch from rotary axis to mill spindle mode, we call it, you know, running the spindle to running the laser. And when they click any one of these buttons, it converts the settings to laser mode, spindle mode, or, you know, it calculates their, you know, their steps per unit on their motor for their rotary axis. And then if they have a laser mounted on their machine, then I can move the router to the laser position and re-zero out, or the laser to the router position and re-zero out, so they can run both laser and router on the same job. And their zero never, their home position for that job, you know, their datum never changes, right? Whether they're running a laser or not, laser will move to the datum position and re-zero there, or the router will move and re-zero, you know, either one. All right, everybody. Long story short, it didn't mean to be a show and tell on Planet CNC, but I had to show the G code and everything. So tape splitting, right? Splitting post processors, getting back to the post processor and everything. Once again, there's that code right there. And you need this header right here. It needs to know that you're added that section. It needs the section header. So give yourself a line space under the, you know, the file name. Give your file name a proper name, right? Put that header in there and just copy and paste one of the other headers, you know, so it's all perfectly the same. Give yourself a space, put in the code, give yourself a space, and then that's it. Save your file. And if there's an error, it'll tell you there's an error, just like it did with us, you know. But I hope you all like this class, because everybody's been talking about it and all. And the one person that's talked about it most, tape splitting, is Brooks Martin. And I don't think Brooks is in the Spindle TV exclusive class. I think he's in the public classes. I think he's in the Spindle TV public classes, and so he's going to hate that he missed that that class. That's what being a Spindle TV exclusive member is all about. There's still more to come for being a Spindle TV exclusive member. So if you're a member, stick with it. And trust me, very soon it's going to be money well spent. I'm working on it religiously. All right. Yeah, Kurt, email me with whatever you want to email me with. That's fine. All right, ladies and gentlemen. Well, listen, it's a late night. We're going to go ahead and 10:36 tonight, this evening, hour and 52 minutes in. There's no more to really talk about when it comes to tape splitting. Now, I will say this. There is a video. There is a video that is on YouTube. There is a video on YouTube, youtube.com. Tape splitting. Yeah, and you're going to get a lot of drywall tape splitting videos right here. So this is Brooks Martin. Brooks Martin, there you go. Brooks Martin. So tape splitting the nuts and bolts with voiceover. So Brooks Martin has an 8-minute video on tape splitting. Give it a look. Brooks Martin right there. Tape splitting the nuts and bolts with voiceover. So, and Brooks, he's got, if you go at his channel and everything on his videos, he did, I don't know if you remember the lion shield that we did not too long ago, right? He did his version of the medieval shield and his take on it and stuff. Good video. And then adding bitmap textures, then hand corbels, all kinds of cool little videos that he's got on there and everything. So cool stuff. Check out Brooks's videos and channel, subscribe to him and all that stuff. And yeah, that's that. All right. All right, we got one more question popped up. Let me get to it here. Hats, they still are not in yet. Now they're who is it? My hair's a mess. Sorry, guys, girls. But Vernon Company, they're not in yet. But as soon as they are, trust me, because I had to spend $3,000 on hats. Right, I had to buy $3,000 worth of hats. So as soon as they come in, you can better believe they're going up for sale. I will be making that announcement. And buy, ladies and gentlemen. I got to make that money back somehow. I don't know exactly the price of them yet. I got to wait to see what my total offload was, and then I'll kind of price the hats. But they're going to be relatively well priced in there. Mine's dirty as all be it, but they are mesh hat on the back, but they're foam insulated, and they're really nice and cool. But American flag, the Spindle TV logo, all that stuff, and kind of this a little dark, but it's almost like a blue denim and everything. So I will, Brooks, I will let you know as soon as I know. For sure, I will put them out. But they are, they're supposed to be drop shipping soon to me. So I'll let everybody know as soon as I know. Where you at? Right there. I'll let you know as soon as I know. Because I am like, I love my hat. I'd love to have people wearing my hat. So as soon as it's out, I'm going to be putting it up for sale. And, Spindle TV members, you might all, we'll see, get a free hat or at least a big discount, right? But I think we can spare a few. So as soon as they come in, I'll definitely let y'all know. All right, everybody, we are going to say goodnight for the evening. I didn't see any other questions pop up. I hope this wasn't too confusing, but if you're looking a way to break up your long G codes, this is kind of a good way to do it. You saw how it broke up and how it tells you, hey, it created 5 files, and it does a good job. Okay. All right, everyone. We'll catch you next time. Thanks for joining me. Thanks for understanding about moving to Friday. Wednesday, it just couldn't happen. It just with customers, and it almost didn't happen tonight, but I really wanted to talk about this tonight, so I'm glad y'all hung out with me. All right, everyone. We'll see you later. Y'all have a great evening next week. Oh, gosh, wait, don't leave yet. Hey, stay with me. Let me look at my calendar here. This is important. I have to be traveling. So there will not be a class next week. Stay, everybody still with me, hopefully. I'll have to put that in the Spindle TV group and all, but there will not be a class next week for either public or private. I have to drive up to Digital Woodcarver, Indiana, and I'm going to be up in Indiana for a week working the open house and paid training courses and stuff up there. I'll be teaching Spindle TV or Digital Woodcarver owners. I will be back the following week, which is I'll be back, the 11th. So we will have a class on the 14th, May 14th, but we will not have a class on Wednesday, May 7th or 8th, Thursday. No classes next week. All right. And Tuesday, the 29th, today's the 25th, Wednesday, the 30th, we will have a class, but that's next week. We will have a class next week because today's only the 25th, but this class of the week after, there's not a class for that week. All right, everybody. Y'all have a wonderful evening. We'll catch you later.